So hello everyone, and welcome. It's a real pleasure to have you with us for today's masterclass Parametric Design for Real-World Impact Beyond the Final Project. Thank you for joining us. In this session, we will explore how parametric design can move beyond the classroom to generate real-world architectural solutions. We will begin with a modular workplace developed as the final course project of the postgraduate program in parametric design with visual programming in BIM and a design that integrates sustainability strategies and advanced computational tools. And today's speaker will present this final course project, which was awarded the best final course project in the latest edition of the program. And then we will look at some professional case studies that bring parametric concepts into real practice, showing how tools like Grasshopper and Dynamo help transform creative ideas into buildable solutions. So this masterclass aims to inspire you with practical examples of how parametric thinking supports innovation and efficiency in design. My name is Thaisa Figueroa. I'm Institutional Relations and Program Manager here at ZIGURAT, and it's my pleasure to be your host today. And before we get started, for those of you who are not or who are new to ZIGURAT, we are a global online education institution with over 20 years of experience in e-learning. We offer master's and postgraduate programs in architecture, engineering, and technology management, supporting professionals from all over the world in advancing their careers. And we are proud of our diverse and vibrant community with more than 20,000 students from over 120 countries. Uh, let, let's try to make, I always try to make the session a little bit interactive. So I invite you to put it in the chat, drop in the chat, where are you joining us from? Let's try to build a dynamic and engaging experience together today, okay? So please send us at the chat, where are you joining us from? I'm joining you from Barcelona today. So let's see where are you? And today's masterclass is directly connected to the postgraduate program in parametric design with visual programming in BIM, a 4-month course designed for architectures, designers, and engineers who want to master tools like Grasshopper, Dynamo, Python, and Blender to create smarter, more efficient workflows. So one of the key highlights of the program is the course final project, where the students apply everything they've learned to develop innovative, buildable designs. So today you will see a great example of that in action through Marino project presentation. The next edition of this program starts in October. So if you are ready to boost your skills in parametric design and BIM-based programming, this is the perfect opportunity to join. So please feel free to scan the QR code on the screen to learn more about the program. And now I'm super honored to introduce our speaker for today, Marinos Skouras, architect at OODA Architectural Design Studio and alumni of our postgraduate program in parametric design with visual programming in BIM at ZIGURAT. A quick note before we pass the floor for Marino is please feel free to drop your questions at the chat and we will address them at the end, okay, in the Q&A session at the end of this session. Marino, thank you for being here with us, and the floor is all yours now.
Thank you very much, Tasha. Thank you also very much, and thanks to ZIGURAT Institute for giving me this opportunity in presenting today's my thesis and some projects. So I'm going to share my screen. Okay, hello and everyone and welcome. Thank you so much for joining today's masterclass. I'm really excited to be here and to share my recent work and experiences with you. My name is Marinos Skouras. I'm an architect, and I'm a recent graduate of the Postgraduate Programme in Parametric Design and Visual Programming in BIM at the ZIGURAT Institute. So over the next hour, we will explore how parametric design can go beyond academic projects and have a real impact on professional practice through tools like Grasshopper and Dynamo, and through projects that I've worked on at OODA and in collaboration also with the HAVELAR company. I hope this session gives you some inspiration and practical insights, and maybe even some new ideas for your own work. So let's get started. The first project that I'm sharing right now with you is my final postgrad thesis, and I will talk about my experience in the postgraduate program, and I will explain my working process through the different modules. So starting with the overall structure of the program, it lasted around 4 to 5 months, with I think Christmas vacation included, and it was divided into 4 main modules. These modules are like separate chapters where we'll be taught different things in each chapter. So the lessons that were provided, they were either live or recorded, and it gave me the flexibility to follow them at my own pace and also adapt them to my personal schedule, which in the end has been proven really helpful in order to move the project forward and finally be able to create like a fully parametric design. Looking more closely at each module, module 1 was an introduction in programming where we worked with Python using Google Colab. For those that don't know, Google Colab is an online platform where you can write and you can test your own scripts, and you can see if your scripts are functional and if your scripts are working. And it's a really good platform for beginners in order to test their coding there. Module 2 focused on programming with Python within an OpenBeam framework and mainly using Blender's Python environment. This was, for me, it was quite a steep learning curve, as I wasn't familiar with Blender or with OpenBeam concepts before. Then module 3, it was an introduction to visual programming with Grasshopper, where we used Rhino and the plugin Grasshopper. And we also had some explorations of ArchiCAD and Revit. Although I had used Grasshopper before, I was not yet comfortable enough to create a full parametric design on my own. So this was the best opportunity that I was given in order to be able to do so. And finally, module 4, we focused on using Dynamo, which is similar to Grasshopper, is a different kind of visual programming, but it's slightly, I felt that it was slightly more complex in terms of usability. So a few words about each module. Regarding the module 1, programming in Python was completely new to me, and it took me some time to understand the logic and the possibilities behind coding. At first, like the material that was shared by ZIGURAT Institute, it felt like really overwhelming, and I wasn't sure where to focus on. But however, eventually I realized that the goal was not to master everything right away, but it was important to build like a strong foundation that I could later expand on. Module 2, it was definitely more challenging, and we went deeper into Python and we were introduced to OpenBeam. We learned about IFC documentation, about libraries like IFC OpenShell and Bonsai. And through this, we learned how to manipulate IFC files to extract information, to create schedules, or to automate tasks. And it was a really valuable and interesting module. And it's also really interesting for people that are into BIM softwares. In module 3, this was like where we focused mostly on Grasshopper. We start learning and using Grasshopper, and we explore how it connects with other softwares like ArchiCAD and Revit. Our main task here was to design a workspace building all parametrically, or all designed through visual programming. So we were provided with a site plan, and we had to design within that context. This module was particularly challenging and required a lot of focus and a lot of discipline to move forward. And it's not something that you learn in one day and that's it. It requires like constant experimentation and like try things out. So here these are the steps of my final project. As you see, it's consisted of multiple interconnected definitions, all working together to generate the building form parametrically. Unfortunately, I don't have right now like a video demonstration to show you how like the whole workflow, but I have this set of images and steps that can explain step by step my design process. In some cases, I even developed some Python scripts to bridge what we learned in Module 1 with Grasshopper. And also it helped me to tackle some difficult issues that I have and some tasks that I couldn't achieve with using Grasshopper alone. So one of the best aspects of this module was like having weekly assignments which kept me on track and helped me to maintain steady progress throughout the whole process. So here you can see the first step in the first set of images. It's where I get the plot polyline as an input, the plot of the building that we are supposed to design, and then I made a spiral curve within the plot dimensions, and after that I extruded the surface. And on that surface, I projected a grid of points. In that case, I didn't want to use all the points and I want to select some of them. For example, let's say that you have rows A, B, C, and D with points. So in that case, I use the Python script that selects from row A and C the odd number points, and from row B and D the even number of points. So after having all this group of points, I assigned on every each one of them boxes that finally represent the workspaces. After that, I made a radiation analysis on each box, and for that, the ones that are more exposed to the sun, I applied the rotation parameter to avoid having surfaces receiving direct sunlight. So in that case, I put up to 30 degrees of rotation. And I realized that this also gives the feeling of a more dynamic facade design. Regarding the retail and exhibition area, that it had to be in the ground floor and we could only go up to 2 floors. So in that case, I created another Python script that makes sure that I'm not exceeding the maximum building footprint. And if so, it will the script itself, it will automatically add an extra floor. And also it will make sure that it doesn't exceed the maximum gross area, which was 5,000 square meters. So let's say that I design like this spiral, and it calculates that the maximum area it's more than the permitted footprint. So it will add just an extra floor. So in that case, it will not exceed the permitted footprint. Then after that, I designed a staircase into 2 parts, and it adapts to the number of the floors that we're using for the retail and exhibition areas. So when we have 2 floors, both of the parts of the staircase are being used. When we have 1 floor, only the first part of the staircase is being used. And then regarding the structure, each column of boxes, it has a structure that runs through it. It was kind of simple, and since like each row, each column had the structure, all of them in the end joined together and provided the support that the building needs. And lastly, as a last step, we had to separate all the elements that we used into categories. So that way we could later import them to Revit. So we had to separate them in categories like slabs, like walls, like windows, structure as well, and then it will be easier for us to import this file into Revit. And after all this effort, I finally managed to deliver my first complete project and to create a fully dynamic and responsive design, which was really exciting. And also it's really interesting to see how key parameters, they could be adjusted to control the building's position, the rotation of the building, the shape and the height. And here you can see how dynamic and flexible the building has become. So here on the first set of images, you can see that you can adjust the size of the spiral, the size of the building. You can make it like either bigger or smaller, and that will have a change also on the ground floor. You see on the second set of images from the left, you have, for example, 2 floors on the ground floor because the area is like too small. And then as you move lower, you can play with the number of heights, how many floors you want to have. You can have like as many floors as you can, or you can go like really low, creating like this dynamic game. Also, regarding the boxes, in my project, I chose to use squarish boxes, but of course you can adapt you can adjust the sizes of the dimensions of the boxes, and you can make either rectangulars, or you can create like whatever shape you want. You can make them like spheres, or you can make them like curvy boxes. And then in the end, you can focus like on the solar rotation. So you can decide either to have 0 rotation on the boxes. That way you can have a facade that it's more uniform, or you can apply the rotation parameter. That way you can have a more dynamic facade, and you can also like make like spaces that are more comfortable in terms of interior. And I have to say that Grasshopper's powerful parametric tool, it made it possible to quickly modify and optimize the design. That way it makes the process much more efficient and flexible. Now, moving on to module 4, the transition to Dynamo, it was a little bit smoother since we have already seen how visual programming is while we were using Grasshopper. So the whole logic, it was like more or less the same, and it was easier to grasp like what is going on. In this module, we used Dynamo as the main tool, along with Revit, AutoCAD, and Excel. So in some cases, we imported some AutoCAD files, we imported some Excel files, we gave data back to Revit, we took that data from Revit, and our main task here as an assignment was to retrieve, to manipulate, and to return data to the project that we worked on the previous module. So one of my focuses in this module 4 was the shading system optimization. My first step, as a first step, I had to create an Excel file from Grasshopper with the radiation values each window has. For example, what is the exposure on each window? Then I imported these values in Dynamo, and I also imported the surfaces, the windows, and I tried to analyze window exposure to sunlight and proposed customized shading system for each window. So to do so, I created a threshold that divides the windows into 3 categories. If the window is highly exposed to sun, then it will receive overhangs. And if the exposure is medium, it will receive fins. And if the exposure is low, then the window will not get any shading system. So the script I developed, it has potential to be applied to other similar tasks as well. This is the interesting thing with visual programming. You can create, for example, scripts that you cannot just like do it for one project and then discard them. You can always like reuse the whole script or parts of the script for your next project, which is like really efficient in the end. And the interesting thing is that by doing this shading system, it didn't only improve the performance and the interior condition of the building by avoiding having overexposure to sun, and by providing the necessary shading for each box, it also creates an appealing and playful facade, which is in architecture is really interesting to combine both functionality and aesthetics. Another important part in module 4 was trying to calculate the carbon embodiment. This was a little bit tough, but because I had to start searching in libraries like EC3, which is the embodied carbon in construction calculator tool, where I gathered information about carbon intensities of materials. Using Dynamo, I created a routine to efficiently calculate the carbon footprint by importing this Excel that I created. And I managed to extract this information into an Excel file and even create a chart for a better understanding of which materials have more environmental impact in my project. And this, in later stages, it can help you optimize the materials and propose alternative materials with lower impact. But in that specific case, the analysis wasn't really expensive. However, the script is ready to be applied for all materials. Although I only had time to calculate the carbon footprint for the walls, this is an area that I'm really interested in exploring further, as I want to design projects that are more environmental friendly. Some final reflections on each module. Regarding module 1, I felt that I gained the basic Python skills, which I'm planning to use them to improve workflows and automate repetitive tasks. In module 1, although it was really challenging, it made me very curious to explore OpenBeam concepts further, which if I ever get the chance, I will go straight for that. In module 4, I learned parametric design, and that I can use in whenever I want to do environmental optimizations. As an architect, I definitely plan to apply all these what I've learned to create more intricate and appealing and sustainable design projects. And in module 4, I felt really motivated to develop my Dynamo skills further and to focus on data extraction and environmental analysis, and to create more intelligent and responsive designs. So this was the presentation of the first of my thesis. Now we're moving on to the next project. For those that do not know, OODA is an architecture and design studio which is based in Portugal, with projects in all Portugal and also international projects. So for the past few years, I have been part of this team, of OODA team, and I have worked on many projects. However, this specific project was the first one that I managed to apply fully parametric design. And it's the one that I'm going to present right now, and it's called Bond Tower. So Bond Tower is located in Tirana, in Albania, and it faces Drita Knox Avenue, which is an important axis that connects the airport to the city center. And of course, in Albania, there's a rapid construction. It starts they start building a lot of new buildings, and this street is currently undergoing rapid transformation. And there are many large-scale developments that are emerging. So as with many of our projects at OODA, we began by studying the site, and we analyzed key characteristics such as the sun path, the surrounding views, and the building constraints, like the maximum footprint and the height of the necessary height that we should go. So to integrate these constraints into the design process, I translated them into parametric definitions using Grasshopper. So I create adjustable sliders for floor count, floor height, and for like building dimensions. This flexibility allowed us to adapt the design easily as the project evolved further. And here also you can adapt like the number of the balconies that you want to have. A few things about the program of the building. Bond Tower is primarily a residential building with apartments located on the upper floors, and in the middle section houses hotel and office spaces, while the retail and the parking are positioned at the base of the building for easy public access. My main focus was to design a facade that I developed entirely in Grasshopper. Parametric tools, it made it easier to experiment freely and to iterate efficiently throughout the design process. The concept of that facade was inspired by traditional carpet waving techniques, where threads interlace to form like intricate patterns. So what we try to do, like we try to translate this logic into architecture, creating like a facade that weaves horizontal and vertical elements together while it accommodates vegetation. And this is how we ended up setting three basic core ideas that guided the facade development. The first one was to intertwine vertical and horizontal elements. The second one was try to get like a gradual transformation from flat to zigzag geometry. And the third one, it's about the progressive expansion of the facade in order to create diverse flower bed sizes. So once the design principles were set, it was time to switch to Grasshopper and start working. The Grasshopper script, consists of quite complex workflows and calculations, and it's quite big. So I'm not going to analyze everything in depth right now. So for that reason, I'm going to keep it simple and mention that we defined only 6 layers that will be the part of the facade. These will be the slabs, the parapet walls, the flower beds, the railing, and the columns. This video shows how we parametrically control the parapets, how we can control their height, how we can control the thickness of the parapet, and also the offset from the slab. And these settings can be easily adjusted to accommodate design changes. And here you can see the columns that they span every other floor, and that way they give the sense of a floating structure and the feeling that the elements are interlaced. Their thickness and their shape is also fully adjustable within the script. So finally, the result was a fully parametric facade that responds to the original design intentions, and it offers both formal expression and functional adaptability. After that, we conducted some radiation analysis in order to assess the solar exposure on all facades. And the new facade geometry, we saw that it managed to reduce direct sun impact and contributing that way better to thermal performance. One really interesting and outstanding feature for this project was the system of flower beds, which increases in size as you go up the building, allowing that way for more space and vegetation on higher floors, giving the feeling of making like a tree. This video here demonstrates how we can adjust the flower bed dimensions depending on how much space we want to give for that. we can adjust the depth of the flower bed, or the height of the flower bed, or we can remove some flower beds from any floor that we want. We could also resize the interior floor space, and that way we can allow for more flexible balcony layouts. You can make the interior space smaller or bigger according to what your needs are. So the variation in flower bed size, it gives us the opportunity to create a layered planting strategy, which was developed in collaboration also with P4, which are some landscape architects here in Portugal. And we proposed on the lower levels small plants like aromatic plants and herbs on the more exposure balconies, while on the less exposure balconies, we chose species with dark foliage that can withstand less sun. Mid-levels, they host shrubs that are more resistant to wind and cold. And as we go higher, we move to taller eye-catching shrubs. And then in the end, the upper floors, they support small resilient trees. And that way they add a scenic and ecological value to the building. Through a parametric approach, we were able to design a facade that it's not only visually engaging, but it's also adaptable and context-aware. And the use of Grasshopper, it allowed us to embed flexibility directly into the design logic. And that way, it enables us to make quick iterations and responsive adjustments throughout the process. Now I'm going to move on to the third and last project for today. So this project that I want to share with you, even if it's quite small, it's really exciting because it involves 3D printing, which is a rapidly evolving technology with huge potential in construction. So this project was in collaboration with HAVELAR. And for those who don't know, HAVELAR is a young eco-construction company which is based in Portugal. And the name stands for Having Home. And their mission is to deliver fast, affordable, and sustainable housing solutions. So this company was created in response to three pressing challenges. The first one is the housing crisis, which is super acute in Portugal. And we notice also in Spain as well, that the rents and the house prices, they skyrocketing, they're really high. So they offer a solution for more affordable housing. Another crisis is the climate crisis, and we know that climate change is real. And we also know that the construction industry is responsible for nearly 40% of the total CO2 emissions. And finally, the construction crisis with rising costs and material shortages. So in order to tackle these issues, HAVELAR, they use 3D printing to accelerate construction, lower cost, and reduce waste. So what they're doing, they're designing high-quality homes with leading architects, and each architect, they're collaborating with famous architects that they can provide design. So everyone has accessibility to this design. So HAVELAR are also committed to share this design to everyone and also to carbon neutrality. A few things about the 3D printer for those that are not familiar with 3D printing in construction. A 3D printer in construction, it works much like desktop 3D printers. So you have a digital 3D model, which you can create in your laptop, in your PC using a 3D software, for example, Rhino. And then when you have it, you have the design done. this design can be processed by the printer, which uses a mix of aggregates, water, and binders. And this material is being pumped through an extruder, and the printer arm builds the structure layer by layer. So in the end, you can have like a replica of the digital model that you have done. Here's a quick overview of the 3D printer used by HAVELAR. You can also see the allowed printing dimensions. However, we will not go into more technical details. And in this video, you can see HAVELAR's 3D printer, how it looks while it's operating. And you see that it's moving slowly and steady, and it prints layer by layer. Another thing, as I mentioned about, as I talked about carbon neutrality, it's really important to note that this team is actively exploring alternative material to reduce cement and to improve sustainability. So in addition to concrete, they also experimenting with earth-based materials and other low-impact alternatives. So in this image, you can see concrete 3D printing on the left, and on the right, you can see earth 3D printing structure, which is consisted of earth, water, and I think some fibers for that they serve as binders. So they're doing this experimentation because their short-term goal is to reduce cement. And we know that cement, it's the binder that it's responsible for the CO2 emissions among inside concrete, that it has aggregates, water, and cement. Cement is the one that is responsible for the CO2 emissions. So their main goal is to try to reduce the use of cement and eventually reduce the total CO2 emissions. So they're trying to reduce it, and their long-term goal is eventually to achieve carbon neutrality and in material sourcing. So back to my work now. For this project, my task was to design a custom wall for one of HAVELAR's prototype homes, which is the LAR 1.1. And this project is a 2-bedroom unit that it's made out of concrete, 3D printed concrete walls and a wooden structure and a roof. When it comes to 3D printing, it's really difficult to 3D print roofs. So that's why we came with the solution of having a structure that was made out of wood. And you can see that the 3D printing of the wall, it lasts only one day. Like in one day, you can 3D print the walls. And the total construction of this house, it can be constructed in only 16 days. So in that part, my focus was on the exterior wall design. Using Grasshopper, I was asked to create a curtain-like surface with random curves that play with light and shadow, and that way it adds a texture and a depth to the facade itself. So I began by categorizing by taking the center lines of the walls and categorizing them into straight, wavy, and wavy types. The ones that I select here are the wavy curves and are the ones marked in red, while the straight ones are the green ones, and each treated differently in Grasshopper. So I defined basic parameters such as the wall height and the thickness, which are key constraints based on the printer's extruder. And to create this wave effect, I divided the wall into the wall curves into segments, and I scattered the points randomly. Then I reconnected them to form a flowing organic surface. And some more adjustable parameters that I used are the offset distance, the curve division, which is the wave density, and randomness seeds for top and bottom. So that way you can always create like new waves that are never like the same as the previous versions that you had. Some more adjustable. One technical limitation was that the curve radius couldn't be smaller than 5 centimeters, as the printer couldn't handle tighter curves. So I wrote a Python script in Grasshopper to flag any violations, allowing for quick adjustments and validation. Right now, you see that I got a message of an error saying that the radius is smaller than 5 centimeters. So I went back to adjust the parameters until I got the message that all the curves are okay. And then this is like a sign that I can move forward. Here you can see some photos of the actual prototype of the interior, and also I have some exterior ones. And the most rewarding part was seeing like the wall physically printed and constructed. For example, in one day you design it in your PC in the office, and then on the other day you can see it already printed. And it's rare to see a digital parametric design materialize so quickly and precisely in real world. So what I've learned from working with HAVELAR, it's like 3D printing offers a new kind of freedom. And what would be time consuming or costly with traditional construction, it becomes really fast and feasible. And that way it opens up a space to explore patterns and forms that were once impractical. And that was the end of the third project. And to conclude this masterclass, I would like to share some thoughts regarding my postgraduate program. I think that the experience that was provided, it gave me like a strong foundation in parametric design and BIM, and it really changed how I approach architecture. And I got this shifting from fixed solution to adaptive and data-driven processes. So I've managed to actively apply these skills in real projects, mainly through Grasshopper for now, but I'm really willing to explore also other softwares. And these skills, they help me improve design performance and sustainability by making design logic more transparent and responsive to change. Although the postgraduate program was intense and short, it was deeply rewarding, and I'm really excited to continue developing these skills and explore how computational design can drive more intelligent and sustainable architecture. So I hope this masterclass gave you a glimpse into the kind of work that we're doing and the potential of parametric design to rethink how we shape the built environment. Thank you very much.
Perfect. Thank you so much, Marino. Let me get back my screen here. Now let's move for the questions. Besides the people start sending the questions, I will ask you, Marino, one thing. For someone just beginning with visual programming tools like Grasshopper or Dynamo, what would you recommend as the first step to start thinking parametric or start this computational thinking? So what do you
What I would recommend, like first, like forget everything you knew about like design. This is like a new whole approach, and I think the moment that you should start exactly as I start with learning a little bit of Python, and I think this helps you. This is where you make the switch and you change from thinking like a designer into thinking more with data. And I think like start getting like to know parametric design, you should start on by programming, and then you should like apply this knowledge to visual programming. I think this will be like the best start.
Great, great. And from your perspective, where do you see the parametric design heading in the coming years? With the AI and everything, how do you see it?
I've seen that there are like there are quite a few softwares that right now that they're combining AI and parametric design, and I see that it has a lot of potential. Like parametric design, it's for me, it seems that it's the future like way of designing. And you can do, as I mentioned, you can it can improve in terms of time and efficiency, like a specific type of, like a certain type of design. For example, when you're doing something, let's say manually, it takes like a lot of time. And every time that you need to make changes, you need extra time to make these changes. But using parameters, it's like super quick and super easy. For example, if you want a building to have, I don't know, less balconies, you have just one slider and you can adapt it. Of course, in this case, you should find which is like the middle point of all this, because I'm not saying that it's you should design everything in Grasshopper and everything in visual programming. You should see which parts make sense for you to design there and which parts not, because they're like many times you're getting lost in trying to design the every single detail, and then in the end there's like a chaos, like, and your screen is like chaotic and you don't know where to start and where to finish.
Yeah, yeah. So you already start to answer, I think, André, but André asked us, like, how does parametric design can help you on your daily work? So if you can tell us some case, practical, simple case that you notice that the
In my
parametric
daily work,
design, yeah,
um, okay, parametric design, in my daily work right now, I'm trying to push a little bit more into like having more sustainable approaches. And using Grasshopper, which is like this kind of visual programming, it helps me do a lot of analysis and create design. For example, passive design that it's parametrically driven. And I think this is, for now, this is what I'm trying to focus on in the work that I'm doing in the office, trying to combine parametric design and sustainability to create, for example, really adapt like buildings that can adapt in different climate restrictions.
great, perfect. I have one last question. It's one personal doubt. It's how the clients and consultants or the clients, they embrace the parametric solutions, or how do you convince the clients to embrace the parametric solutions, especially this one that's more traditional or more cost sensitive? How do you embrace this?
Exactly. Of course, the clients, the moment that you're going to say that this is going to be really efficient and really like cheap, like really cheap, cheaper to build and to calculate, this is what they want. And also the result that parametric design it gives you, it's like there's no comparison. It's like and visual, it's the outcome. It's really interesting. But also when you highlight the fact that okay, having this approach, this like parametrically designed building, like it can help you reduce cost in this. It can help make the building more sustainable, and that way you can save costs and energy costs in long term. I think this is something that every client will like.
Great, great. Marino, do you want to leave a message to our audience, to everyone that are connected now and everyone that will see the recording? So I let you
To leave
this.
a message, the message that I want to leave, it's like I was really excited to share like my knowledge and what I got from ZIGURAT Institute, and I wanted to share with you. And I also wanted to share my final thesis and also the projects and how I'm trying like to apply the knowledge that I got to more projects. And I think this is really important. And the foundation that I got from ZIGURAT Institute was really meaningful, and it gave me like a lot of tools to start experimenting more. So I think that this was the best thing that I can do for my career right now.
Perfect, Marino. Thank you so much. So I I will finish the session now.
Thank you very much.
A huge thank you to you, Marino, for sharing such valuable insights today, your project, and everything that you are working on. And of course, thank you to everyone for joining us today. Let's stay connected. Be sure to not miss our upcoming events. And until then, stay curious, stay connected, and take care. Thank you so much.